Alright everybody, welcome back. In this video we're going to talk about how we can construct polynomials that meet certain characteristics for their behavior. And we're going to work through an example of what that looks like to start. Example 1. Construct a polynomial p of x of the form a sub 0 plus a sub 1x plus a sub 2x squared, etc., etc., with the following behavior at x equals 0. We want the polynomial's value at 0 to be 1. We want the derivative of the polynomial's value at 0 to be 2. The second derivative to be 3. The third derivative to be 4. And the fourth derivative to be 5. And those are just, arbitrary values that we picked to illustrate what's going on here. So we're going to construct a polynomial that has this kind of behavior. So first of all, we start with the basic polynomial, p of x equals and since we're trying to find the behavior of it at all these various derivatives, what I'm going to do is I'm going to take all these various derivatives of this polynomial and we're going to see what happens. Alright, so the first derivative of this polynomial, since a sub 0 is a constant, that's just going to go away. And then the derivative is going to be a sub 1 plus 2a sub 2x plus 3a sub 3x squared plus 4a sub 4 x to the third. And the second derivative of this polynomial is going to be 2a sub 2 plus 6a sub 3 x plus 12a sub 4 x squared. And the third derivative is going to be 6a sub 3 plus 24a sub 4x. And the fourth derivative is just going to be 24 times a sub 4. Alright. And now, what I'm going to do is I'm going to solve for these various values. We want p of 0 to be equal to 1. Well, if we put 0 into this polynomial everywhere where there's an x, all those terms with x's drop out, and we get that a sub 0 has to be equal to the value that we desire, 1. Alright. Then we do the same thing with the second polynomial. We'll put 0 in everywhere here, and we get that a sub 1 has to be equal to the value that we want the polynomial to have. We'll do the same thing with the second derivative. We'll put 0 in here everywhere where there's an x, and we want that value to be equal to 3. So 2a sub 2 is equal to 3. Solving that, we find that a sub 2 is equal to 3/2. Do the same thing for the fourth derivative. We'll put 0 in here for x, and that tells us that 6a sub 3 needs to be equal to 4, and so a sub 3 is going to be equal to 4 over 6, or 2/3. And lastly, we put 0 in for x in the fourth derivative, and there are no x's, so we get that 24 a sub 4 has to be equal to the value that we desire. And so a sub 4 is equal to 5 over 24. And now I can construct my polynomial with the behavior that I desire. All I'm going to do is put these values in to the original general form. A sub 0 is going to be 1. A sub 1 is going to be 2. A sub 2 is going to be 3/2. a sub 3 is going to be 2/3, and a sub 4 is going to be 5/24. Alright, now before we go on to the next example, there's something that I want to point out to you because this is important in this polynomial construction process. Notice these denominators here, and it's not necessarily evident what the denominator was in these, but the denominator in both of these was 1. These denominators follow a very specific pattern. Alright, this denominator is 4 factorial. This denominator here is 3 factorial. This one is 2 factorial. This one is 1 factorial, and for those of you who may not know this one is 0 factorial. And this is going to be something that we use quite a bit in generating these polynomials, because really, in order to find the coefficients, I can develop the general concept that the coefficient is just going to be equal to these values that we want the polynomial to take on, divided by the appropriate factorial term for that term in the polynomial. And that's going to come up a lot in this idea of constructing polynomials, and it's going to come up a lot in the development of something that we're going to do in the future. So, let's see. Let's look at example 2. It's possible to construct a polynomial in a similar fashion to the one we created above by simply finding the value of the function and several of its derivatives at the point. Construct a polynomial p of x equals blah 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 that matches the behavior of natural log of the quantity 1 plus x at x equals 0 through its first 4 derivatives. So first of all, the value we want for the polynomial at 0 is the value of this function at 0. So it's a natural log of 1 plus 0. So we want the polynomial to have a value of 0. And then we need the derivatives of this function. And the derivative of the natural log of quantity 1 plus x is just going to be equal to 1 over 1 plus x. And so we want the derivative of the polynomial at 0. Come on, stylus, cooperate. We want that to be equal to that derivative evaluated at x equals 0. We want that to be 1. And then for the second derivative, we want to take the derivative of the quantity 1 over 1 plus x, which is equal to negative 1 over the quantity 1 plus x, quantity squared. And so we want the second derivative of this at 0 to be equal to negative 1 over 1 plus 0, the quantity squared, which is negative 1 over 1. Is negative 1. We want the third derivative to behave like the third derivative of this function, so we're going to find the derivative of negative 1 over the quantity 1 plus x to the second, and the derivative of that is going to be 2 over the quantity 1 plus x to the third. And so we want the behavior of this polynomial at 0 to mimic the behavior of this derivative. So we want that to be equal to 2. And lastly, the derivative of 2 over 1 plus x to the third is negative 6 over the quantity 1 plus x to the fourth. And so we want the fourth derivative to mimic the behavior of that at 0. And so basically now we've deconstructed this and turned this into our first example, only with different values that we desire for the coefficients. Okay, and a sub 0 is going to be equal to p of 0 divided by 0 factorial, so that's just going to be 0. This next one is going to be this value divided by 1 factorial, so 1 divided by 1 factorial is just 1. It's going to be x. This next one is going to be this coefficient divided by 2 factorial, so negative 1 over 2 x squared. This next one is going to be over 3 factorial, so our coefficient is going to be 2 over 3 factorial. 3 factorial is 6. So 2 over 6, which is 1/3. So 1/3 is going to be our x to the third coefficient. And then the last one, we want this over 4 factorial. 4 factorial is 24, so negative 6 over 24 is negative 1/4. So that's going to be our coefficient for our x to the fourth term. And there's a polynomial that represents the natural log of the quantity 1 plus x at x equals 0 through its first 4 derivatives. Alright, that's the end of this video, the end of this lesson. See you guys next time. Have a great rest of your day.